Hello, my algebra doing friends. I thought on Monday that we would do these problems here. If you want to pause the video and come back and give them a try on your own and see how you do, that would be great. Otherwise, here we go. And so these are some bonus problems that I had for the chapters in the chapter 7. So this is 4 over x plus 3 equals 1 over x. So this first one here we're going to give a try to. And so in order to do a problem like that, you would want to clear the fraction. And there's no factoring to do here, it's just x. So the only denominator I have is x. So I'm going to multiply all three terms by x. So I notice here that there's fractions. And I'm going to clear them by multiplying by the common denominator, which is x. So I'm going to multiply, I'm going to have 4 over x plus 3 equals 1 over x. And I'm going to get a different color pen here, and I'm going to multiply this by x. I'm going to multiply this by x, and I'm going to multiply this by x. And I can write this as x over 1, right? That's the same as x. And then the x's would reduce with one another and give just 4 here. And so when we do that multiplication, we just get 4. When we do this multiplication, we get 3x. And when we do this multiplication over here, we get 1, right? The x's reduce. This is x over 1. The x's reduce, and we just get 1. And then now I'm thinking, well, how do I solve that? And I'm thinking, oh, it's linear. We did those in chapter 1, and I just need to get them separated, right? So I'm going to get the variable on one side and the number on the other by taking away 4 from both sides. So on this side, I would be left with 0 plus 3x, which is 3x. And on that side, I'd be left with negative 3. And it's still linear, and so I'm going to divide by 3. And then I have to, so there's my answer, and I have to make sure that it checks. And so if it makes the denominator 0, then that means it's an extraneous solution. If it doesn't work, then that means I made a boo-boo. And you're going to check back in the original problem. And so right here where we have x, we're going to be putting in, instead of x, we're going to be putting in negative 1, with or without the parentheses, because that's what we said x was. And then you could get out your trusty calculator if you like. And so there's my trusty calculator. My cat's nagging at me. She's saying, is it dinner time? And I'm thinking, maybe it is. And she definitely thinks it is, with or without parentheses. So that's the left-hand side of the equation, and I get negative 1. So I just put this in my calculator. You could do that in your head as well, and I got negative 1. And on that side, I could do that with my calculator or my head, and I get negative 1. So they were equal to one another, coincidentally equal to negative 1. So it's that's our answer, negative 1. So our answer here, it's a coincidence that both sides are the same as our answer. That's a coincidence. Okay, then this one here, this example, it's asking me to solve it. And it doesn't just have x, it has x squared. And you've probably seen us when to get the common denominator, right? You factor the pieces. Well, x doesn't factor, and x squared is x times x. And so when you're building that lowest common denominator, this guy says you got to have 1x. This guy says you got to have 2x's. So it is 2x's. And so you could call it xx or x squared, your choice on that for the common denominator. And I'm going to be multiplying every piece by that. So I'm going to go right here and I'm going to multiply by x squared. I'm going to go right here and I'm going to multiply by x squared over 1. And then I'm going to multiply right here by x squared over 1. And I can put parentheses around that whole thing if it makes you happy. It's seeming like it was going to make me happy. So when I did multiply this together, I got x squared. When I went and multiplied those together, and you can verify that one of the x's, right, x squared, is the same as x times x. So an x will cancel with an x and leave over minus 3x equals the x squared cancels with the x squared and leaves minus 2. So it was fractions. So I cleared them. And now it's quadratic. It has raised to the second in it. It has x to the second. And so what you want to do when it's quadratic is you want to get 0 on one side. So I'm thinking about adding 2. So when the dust clears, I'm kind of sticking that 2 at the end there. I'm going to have x squared minus 3x plus 2 equals 0. And when it's quadratic, you get 0 on one side, then you factor it. So I'm going to be factoring. So to factor this, it's going to be 1 times 2 to make 3. They're the same sign, both negative. So this is x minus 1 times x minus 2 equals 0. When we set the pieces equal to 0, x minus 1 equals 0, or x minus 2 equals 0. So we're going to get x is 1 for one of our solutions, and x is 2 for the other solution. And I have no room to check here, and because I didn't give us enough room on this problem, so I'm just grabbing some paper, and I'm going to check on my scratch paper here because I'm just out of room. When you check in the original equation. So 1 minus 3 over x equals negative 2 over x squared. And I like to, and I have in the past, instead of putting my x's, I put in parentheses. And we're going to be plugging in with 1. So you check them one at a time. So right now I'm checking x is 1. So when I put in here 1 and put in there 1, I'm going to use my calculator to figure out what that is. And I could use my calculator to figure out what that is. You could use your head too. Doesn't matter. And so using either your calculator or your head, 1 take away 3 is negative 2. And on that side over there, I get negative 2 divided by 1 is negative 2. So 1 checked. And now I want to check my other possible solution, which was x is 2. X is 2. So 1 minus 3 over so we're going to be putting in 2 and see what we get. So this is 1 minus 3 halves, and that's negative half, whether you do that with your calculator or you do that with your head. And then equals, and then this is negative 2 over 4, which is also equal to negative half. So these are equal to one another, and so 2 is a good answer as well. So both of them checked. Do you want it up there, girl? Okay. I had to move my studio around, and so everything's kind of confusing right now at my house, and no one knows how to act, including the cats. Okay, so in this example here, I'm trying to solve for x, and I notice, oh, it's got fractions. So what you want to do is you want to clear, I wrote factor instead of fractions. And so what you want to do is you want to clear those fractions. And how you clear the fractions is by factoring the denominators so that you can see what you have. So x squared minus 25 is my friend, the difference of squares. So now that I have done that, this doesn't factor, right? And this doesn't factor. And you build the common denominator, the lowest common denominator, by the pieces. So this says it has to have a binomial x plus 5 and an x minus 5. And this says, yeah, I agree, an x minus 5. So I'm putting these pieces over here. And there's no reason to put two x minus 5s because it says it has to have one x plus 5 and one x minus 5. And this says it has to have one x minus 5. And this one says it has to have one x plus 5. So it certainly does. So we're going to be multiplying here every piece by that common denominator. X plus 5, x minus 5. X plus 5, x minus 5. I'm out of room. And then here, I'm going to put it on this side, times x plus 5, x minus 5. And of course, I'm here to cancel. This is over 1. And these both cancel. So this, when I do all that multiplication there, I get 10. When I do this multiplication here, I almost run myself out of room there, minus, the x minus 5 cancels with the x minus 5 and leaves x plus 5 times 1. So since that was a 1 up there, I can be, here's the 1 times x plus 5. And then equals, and on this side, the x plus 5 with the x plus 5 and leaves 3 times x minus 5. So I am going to do the multiplications now. It's looking linear now at this moment. It's not looking quadratic to me. And so when I do these multiplications, so I get 10 minus x minus 5. Ooh, I was going to put an arrow instead of a 5. I don't know why. Equals, and then 3x minus 15. And combining like terms, that's what you would do when it's linear. So 10 take away 5 is 5, so this is negative x plus 5 equals 3x minus 15. And then I'm going to get the variable on one side and the numbers on the other, so minus 3, try to get them separated here, minus 3x, and also minus 5 at the same time. So when the dust clears here, I get negative 4x and equals negative 20. And when I divide by negative 4, I get x equals 5. But you always have to check your answer. These are always check. Anytime that you solve something that had fractions in it with a variable in the denominator, you have to check. So when I go to check, and you check in the original equation, 10 over, so here I am in my checking, that squared minus 25 minus 1 over that minus 5. So instead of the x equals 3 over. So we're going to be putting in 5. And if any of your denominators are 0, then that means this is an extraneous solution and not really the solution. And you notice that this denominator right here, 25 take away 25 is 0. And so this is right here, 10 over 0. And what that means, because you're not allowed to have 0 in your denominator, is that this is not really a solution. It's extraneous. It was a solution to the linear equation, but it wasn't a solution to the fraction equation that we had there. Now, you might have not have noticed. You might have went, like I had been doing and put it in my calculator. But if I put it in my calculator without noticing, right? So I try to notice, is the denominator 0? But let's pretend like I didn't see that. And so if I didn't, that was a 25, right? And then if I didn't see that, I would have something like this going. If I put it in just like I see it, including parentheses and everything. And when I do it, my calculator says math error. It tries to tell me, hey, the denominator's 0. So even if you're a person that puts it in your calculator. Now, and so this means there is no solution to this problem. Okay, so we have just a couple more of these to do, and we'll do them, and so I'm hoping that this video you watch whenever you want to, and then I'm going to put it out, and then I'm hoping that you come to the conference Zoom for question and answering. So this is fractions here. I notice these fractions. And so how you solve things that have fractions is you factor the denominators and then you multiply to clear the denominator. And so the x minus 4 doesn't factor. So this is 3 over x minus 4 equals, I'm leaving myself a lot of space here, 2x over x minus 3. That didn't factor either. Plus, and I'm leaving myself a lot of space here, 6, but that will factor. And to make 12, 3 times 4, right, and adds to 7, needs to add to 7, and both have to be negative. So this is x minus 3, x minus 4. And so our lowest common denominator is, has to have an x minus 4, so we'll put it in there. Has to have an x minus 3, so we'll put it on there. Has to have both, it has both, so great, there's our common denominator. And then what we're going to do with that is we're going to multiply every term, and I left a lot of room so that I could write on either side. So times, and then x minus 3 times x minus 4. It doesn't matter which side you write on, over 1. And I think I'm going to write this on this side too. I say it doesn't matter, but then sometimes it's nicer if you have a monomial to have it written first. So I'm going to allow myself to scoot that over so that I have room right here to write x minus 3 times x minus 4 over 1. And I'm going to allow myself to scoot this one over too. You're like, you know, you didn't plan right. I never do. Times, and of course, every single piece. And I'm here to do that multiplication. I'm going to do that multiplication, and I'm going to do that multiplication. So I have multiplied all of them. So the x minus 4 cancels, reduces with the x minus 4, and gives here 3x times x minus 3 equals, the x minus 3 reduces with the x minus 3 and gives 2x times x minus 4. And the x plus minus 3 and the x minus 4 both reduce and just give us plus 6, right? And then now I'm going to multiply this together. So I wasn't sure, is this linear or quadratic? But now that I'm multiplying this together, I'm fairly certain that it's quadratic, right? Because there it is, x to the second minus 9x equals, so 2x squared minus 8x plus 6. So because it's quadratic, so this is my thought, quadratic means degree 2, right? I'm thinking get 0 on one side. That's what I'm thinking, right? This is my thoughts. And so, and I like my lead term to be positive. It makes it easier for me to factor. So I'm noticing that if I subtracted 2x squared to that side over there, it would be positive. If I did it the other way around and subtracted 3x squared over to there, it would be negative. And then I would have to factor out a negative. So to make it easier to factor, I'm going to take away 2x squared, both sides. I'm going to add 8x. I'm trying to get 0 over here. and I'm going to subtract 6. So when the dust clears, on this side I get 0. And on this side I get x squared minus x minus 6. And then I'm going to factor that. X times x is x squared. 2 times 3 is 6. And remember, this is a 1, right? Minus 1. And certainly when I subtract those, I get 1. And so, and in fact, it has to be 1 positive and 1 negative. So it's, this one's negative and this one's positive. So this is x plus 2, x minus 3 equals 0. And then when I set the pieces equal to 0, so I'm going to get x equals negative 2 as possibly one answer, and x equals 3, or here, or as another answer. And you have to check them. And so I'm going to, I almost have enough room to check them there, but it would be squished. And so I'm not going to squish. I'm going to just get a side piece of paper here to check them. And so I'm going to check them. I'm going to check x equals negative 2. It doesn't matter what order that you check them in, but you do have to check in the original equation. So this is 3 times x over, I'm putting a parenthesis, right, for x. Okay, so in there we're going to put negative 2. And my eye can't help but try to figure out if any of the denominators are 0. So this, because if it is, then there's no reason to even check. It's extraneous. So that's negative 6 for the denominator. And that's negative 5 for that denominator. And you could do the arithmetic to see what this denominator is. But I know that it was, remember, it was the multiplication of those two. So neither one of them are 0, so it's not 0 either. So this should work unless I have made some kind of mistake. So you can use your calculator or your head to do that. And you could use your calculator or your head to do that, your choice. So I'm going to do my, my calculator. So 3 times negative 2. Did you see how I put a negative 5 in there? That's why I like to have a calculator where you can see what you put in. So we get 1 as the output. So that means this whole thing here needs to be 1 as well. If it's not 1, then we've made a mistake. So it doesn't mean that there isn't a solution if it's not 1. What it means is that we've made a boo-boo in solving. Fraction downstairs. For some reason, it's gotten really cold in my house, and it shouldn't be that cold, but it's feeling really cold, and I'm thinking of yelling out for a family member, bring me a sweater, and 1. And so that means that this is a good solution. Now I'm going to check the other one, and the other one was 3. So 3 over here, the blank minus 4 equals 2 over the blank. And I can't help but notice, and I hope that you guys are noticing too, that when I go putting 3 in, that this denominator right here is 0. And if your answer makes any of your denominators, any one of them, any 2 of them, all 3 of them, 0, but even just one of them 0, it's not really a solution. And so this is not really a solution. So that's our only solution, negative 2. So over here, I'm going to cross that one out, and I'm going to circle this one as my only solution. Okay, And then we have the basketball player makes 8 out of 12 free throws in the first game of the season. If she shoots with the same accuracy in the second game, how many of the 15 free throws attempts, how many of the 15 free throws she attempts will she make? It was hard for me to read for some reason. Okay, so this was the first game. And we're going to set up a proportion like we did in the spooky problems. And so that's where these proportions came from. All of these problems came from your book. I guess I was just too tired to put what problem number they were. But I did get them all out of your book. And in fact, they probably all came from the same section, which was the solving section, whatever that was. So on the free throws, she made 8 out of 12. So made out of, right? So she made 8 out of 12, and then we're wanting to know if that equals the second game. Now, in the second game, we know that she had 15 free throws, but what we don't know is how many that she made. And so we're saying that if her accuracy is the same, so she's not more accurate, she's not less accurate, she's the same on accuracy. And so we could solve this. And there's a variety of ways of solving it. And so I've been getting a lot of emails, people telling me, I don't know why you just don't use some cross multiplication, because this is a good time to use cross multiplication. Our book doesn't use it, but you can certainly use it. And I have resisted, but I got so many emails that I'm going to do it. So what you do is you have to make sure you have one fraction equals one fraction, and then you multiply the numerator times the denominator, a times d, and that will equal the numerator times the denominator, b times c. They call this one the means and that one the extremes. So the means equal the extremes. And my mom used to say that to us when we were little, and it meant whatever we wanted at the store we can't afford to buy. And so, and then in math, it means this. So 8 times 15 equals 12 times x. And if you use the same method of multiplying by the common denominator that we have been using, then you would get to this same point. So 8 times 15 equals 120 equals 12x. And then I just have to divide by 12. And boom, 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 x is 10. So if she's just as accurate, if you had another way of going to solve that problem, and you got x is 10, there is other ways of going, and that's awesome. Okay, so that's this video here, and then we'll be on, today on Monday, we'll be answering questions on Zoom is what we will be doing. Okay, bye-bye.